Good morning, students. In the previous lecture, we have discussed about allotropes, catenations, okay, as well as about the saturated and unsaturated hydrocarbons. Saturated hydrocarbons in which a single bond is there, and unsaturated hydrocarbons means double bond and triple bond. Okay, there may be presence of either one or both, that is double bond or triple bond in the chain. Clear? We call saturated hydrocarbons as alkanes and unsaturated hydrocarbons alkane and alkynes. Clear? The general formula for alkanes is CnH2n plus 2. For alkene, the general formula is CnH2n, and for alkynes, the general formula is CnH2n minus 2. This is the general formula for alkenes and alkynes. For alkanes, N may be 1, 2, 3 and so on. But for alkane and alkynes, N will start from 2, 3, 4 and so on. Clear? We will discuss it also why 2. Okay. In alkane, there is presence of only single bond. That is why ane is used here. It is C, and carbon makes C for the carbon, and carbon makes 4 bonds. So 4 bonds it is making here with hydrogen. Okay, this is methane. But to have the presence of double bond and triple bond, there must be 2 carbons. Okay, for example, 2 carbon chain is there, carbon double bond carbon, then make rest of the 2 bonds of each carbon with hydrogen. Okay, it means to make double bond or to have double bond, 2 carbons are required. That is why N will start from 2, 3, 4 and so on. Similarly for alkynes, triple bond, then 4th bond of each carbon with hydrogen. This is alkyne. This is alkyne. This is alkene. That is ethane. This is ethyne. Clear? Now we will discuss about nomenclature, okay, of hydrocarbons. C. The name depends upon number of carbon present. Okay, it means word root first you have to learn. When it is a C1, C1 means only one carbon is present. Then for I will write here chain length this side. Okay, and here word root. When it is one carbon, it is known as meth. Clear? Here I write for alkane, then alkene, then alkyne. Clear? When it is meth, one carbon meth and single bond is present, then it is methane. Okay, but here we will write nothing, because to have alkene alkyne there must be presence of second carbon also. When it is 2 carbon chain length, okay, it is known as eth. When it is 3, the word root used is prop. When it is 4, it is but. When it is 5, it is, it is pent. When it is 6, it is hex. When it is 7, it is hept. When it is 8, it is oct. When it is 9, it is none. When it is 10, it is tech. When carbon chain is of 11 carbon, then it is undeck. When carbon chain is of 12, it is to deck. Okay, but up to in 10th class you just remember up to 8. Clear? Now see, when it is 2 carbon chain and only single bonds are present, then it is known as ethane. Okay, ethane. When there is presence of double bond, then it is known as ethene. When there is presence of triple bond, then it is known as ethyne. For 3 carbon chain length, it is prop. Okay, if all bonds are present single bond between carbons, then it is known as propane. When there is presence of double bond, then it is known as propene. If there is presence of triple bond, then it is known as propine. It means after the word root, these are the word roots, and for the alkane you will write ane as the primary suffix. Okay, for alkane you will write ene as primary suffix and ine as primary suffix for the alkyne. After this name, okay, after this name you will use these suffix. These are known as the primary suffix ane, ene, ine to write the name. Okay, so this is the work for you. You will write the names for the rest of the carbon chain lengths. Okay, now structure of hydrocarbons. It may be a straight chain, branched chain, or cyclic compounds may be there. Okay, for example, I am writing here uh, one example that uh, C it's a 4 carbon chain length. Make 4 bonds of each carbon. It is with hydrogen, like, okay, with the hydrogen. Sorry. Okay, this is a straight chain. Straight chain means 1, 2, 3, 4. These are linked in a series. These are linked in a series. I can also write it in this way. Clear? It means they are linked in series. Clear? There is no branching. In branching, what happens? The number of carbons will be same. Number of carbons will be same, but the structure will be different. For example, I am writing in this way. The number of carbon is same. Number of carbons same in the chain, but you can see here it is, this is a straight chain, this is also a chain, okay, in which carbons are linked in series. when you will count 1 2 3 4, but in this case, okay, you take from either side, one carbon will not be in the chain. Okay, for example, if I'm taking this length, okay, then one carbon remains outside the main chain. It means the branching is there. If I will take this chain, then this carbon will remain outside this main chain. 1 2 3, okay, it means branching is there. This type is known as branched chain. Okay, cyclic means a cycle will be there, so I can write in this way. Okay, this is cycle. Make the rest of the bonds of carbons. 1 2 3, one carbon, sorry, hydrogen, in this way of this these uh, bonds of the carbon. In a cyclic, make 4 bonds of each carbon. Okay, uh, C, carbon. Okay, carbon 1 2 3 4. In a cyclic also, 4 bonds uh, are there of each carbon. 1 2 3 4, 1 2 3 4. It means each carbon is making 4 bond, as well as they are linked in cycle. So it is known as cyclic hydrocarbon. It is cyclic for 3 carbon chain. It is prop, as all are single bond, it is propane, and it is cycle, so it is cyclic propane. Okay, the name of this is 1 2 3. Okay, 2, 1 carbon, it is meth. Okay, 2 meth. To write the name of this, sorry, meth, il is used, methyl. Okay, then main chain, butane, 2 methyl butane. You can also write is isobutane. Why isobutane? Because 4 carbons are present. Okay, that is why iso means same, as like of butane. Okay, and this is n butane. N stands for normal chain. Okay, it means normal chain of carbon atoms are there, so n butane. Clear? This is the difference, that straight chain, branch chain, cyclic hydrocarbons, these are the examples. Okay, see now those compounds, okay, or the, you can say those, if we are taking the particular case here, hydrocarbons. Okay, if you will notice that here it is four carbons in this example. Clear? How many hydrogens are present? Clear? 1 2 3 4 5 6 7 8 9 10. 10. In second case also, I'm writing here again, this is looking somewhat confusing. Count. C4, 1 2 3 4 5 6 7 8 9 10. It means they have same molecular formula, but different structural formula, but having different structural formula. These are called isomers. These are called isomers. Okay, those compounds having the same molecular formula but different structural formula, they are called isomers. Clear? uh, Now you have already knowledge of what are the cyclic compounds. If I will ask you to write the structure of cyclohexane. Cyclohexane. Can you write it? Cyclo means cycle will be there. Hexane means, ane means a single bond. All carbons will be linked by single bond. Hex means 6 carbon chain, or 6 carbons will be there in that ring. So you can write it as C, C, C for the 6 times. Okay. And make the 4 bonds of each carbon with hydrogen. Okay. This is the structure of cyclohexane. Clear? If I will ask you to draw the structure of cyclohexane, okay, its name is also benzene. Okay, then make in the similar way. First 6 carbons. Okay, then see the 2 double bonds. You can't write 2 double bonds in a cycle. Okay, together for this. Clear? For this cyclohexane, you will write double bond, then you will not write double bond, then again double bond, then single bond, then double bond. It means alternate double bond and single bond is there. Then make rest of the bonds of carbon with 1 hydrogen. Each carbon, okay, 1 2 3 4 bond will make. So this is the structure of cyclohexane. So it was all about for today. In the next video we will discuss the about the homologous series, then about the functional groups. Okay, then we will finish this chapter. Thank you and have a nice day.